Hello. So, last bit we want to do today is on page 193, and we're looking at the top of the page, question 18. Now this links in what we were talking about earlier in the chapter with selections and arrangements, and in this case we're dealing with selections because in playing cards we don't care about what order the cards come in, so that's why we're dealing with combinations in question 18. But let's have a read of the question. Consider a full deck of playing cards. You're required to know that a full standard deck, the one that they're going to refer to, is 52 cards. So we know we're dealing with 52 possible outcomes. In part 1 it says, in how many ways can 3 clubs be selected from 13 clubs? Now this is a subtle introduction to something called conditional probability, and we'll be looking at it more later on. This section of questions is very good for introducing you to ideas that we're going to look at in more depth later. So working through these questions and thinking them through carefully will stand to you in the long run. Now, for part 1, in how many ways can 3 clubs be selected from 13 clubs? So they use the word selected, and we also know we're dealing with playing cards, so we're dealing with combinations or selections instead of permutations or arrangements where we would care about the order. So we have 13 clubs and we are choosing or selecting 3 of them. And I'll write the other way that you would see that. 13 in brackets. You can put that into your calculator, or which again would be the NC or button that you can find on your calculators. It's second function. And on the Casio calculators, it's second function divide button. I don't have a sharp calculator, so I don't know what it is on that. Now, if we do that out, or we could sub into our formula that we know for choosing or combinations as well, either way we are going to get 286. So there are 286 ways of choosing 3 clubs from a total of 13 clubs. Part 2. In how many ways can 3 cards be selected from a full deck of cards? So we have, in how many ways can 3 cards, we're not restricted to clubs in this case, just how many ways can 3 cards be selected from a full deck of cards? So that means we have 52 cards in total, and we are going to choose 3 of them. Again, that can be written as 52, 3. We end up with a very large number, as you might expect. So there are this many ways of choosing 3 cards from a deck of cards when we don't care about the order. Now, final part. What is the probability of selecting 3 clubs from a full deck of cards? And this is where this question becomes an exam style question. If they were being nice to you in exam, they might have gotten you to do part 1 and part 2 to set you up for it, but they don't have to, and they haven't at times in the past. So, what is the probability of selecting 3 clubs from a full deck of cards? Remember that probability of an outcome is equal to the number of ways of getting an outcome, number of ways of getting A, divided by the total number of possible outcomes. Now, how many ways can we select the probability of selecting 3 clubs from a full deck of cards? Well, how many ways can we get clubs? Well, we have 13 clubs that we could be picking from, and we are going to choose 3 of them. So the number of ways that we could choose 3 clubs, number of ways of choosing 3 clubs would be 13C3. That's the number of ways of getting A, our outcome, divided by the total number of ways that we could get 3 cards of any type out of the deck. This is the total number of ways that you could get 3 cards of any kind out of your deck. This is the total number of ways that you could get 3 clubs out of your deck of cards. And again, this is going to get linked back in at the end of probability, and you're going to have the language for it a little bit more nailed down. But this idea is crucial. So when we put that in with the numbers we already know, get the probability of getting 3 clubs will be equal to 286 all over 22100. And I think that simplifies it. Yeah, 11 out of 850. Now this is a critical notion and something you're going to have to get good at for the probability questions. There is, however, another way to do that problem, and I want to point it out to you. It might be a slightly more intuitive way. I am not undermining the fact that you need to be able to get your head around this argument here. You must be able to do questions in this form. But I'm going to show you another way to do part 3. So we're going back and doing part 3 again. We want to know what's the probability of selecting 3 clubs from a full deck of cards. So imagine we have a full deck of cards out in front of us, and we wanted to just take 1 card. So we'll take a simpler situation. I want to take 1 club from a deck of cards. What are my chances? Well, if I want to take 1 club, I have 13 chances out of a total of 52. We're all in agreement if we take 1 club out of our deck of cards, the probability of getting that club is going to be 13 out of 52. Number of ways of getting a club out of the total number of cards. Now I have a club in my hand, and I go to take another card. What is the situation now? I'm going to have 12 clubs left in my deck of cards, so I have 12 chances to get a club out of a total of now 51 cards, because I have a club in my hand. I've already got a club. Now I've taken out 2 clubs. If I want to get a 3rd club, how many clubs are left in the deck? There are 11 clubs left. How many cards are left in the deck? There are 50 cards left in the deck. I want this and this and this to happen. I need all 3 of these to happen in order to end up with 3 clubs in my hand. So I want to multiply. And with probability is always going to mean multiply. So I want to get a club and my 2nd card to be a club and my 3rd card to be a club. Because this and this and this must happen, I multiply my different outcomes together. And when I put that into my calculator, lo and behold, I get 11 out of 580. So these 2 methods are actually logically equivalent. It's not particularly obvious to see that they are, but they are actually very much connected, and you can work that out. I don't suggest you take the time over it, but this is one way of arguing the question, and this is another way of arguing the question. You will need to be able to use both. This is the one that we're focusing on right now. I'm highlighting this to you, and we will come back to similar questions in the future. So that's all we need for now.